All right, class. So we've had practice with finding what the rate of change of a linear function is if we know some information about it. We've also had practice finding what the y-intercept or what the initial value of the function would be if we had some information about it, right? That's pretty much what we spent our last two lessons doing. But what if we were not ever given any explicit what if we, I should say, what if we were not explicitly told what the rate of change of a linear relationship is, or we were also not even told what the initial value or y-intercept of the function that represents the linear relationship is? What if we were given a question like this? A reception hall is available to rent for a party. It charges a flat booking fee and then a constant charge for each party guest. Monica knows that if she invites 30 people to the party, she will be charged $225, and if she invites 55 people, she will be charged $350. Write the function that represents the cost of renting the hall. Okay, so we don't have a lot of information to go on right now, right? We'll find out that we have enough, but at first we're looking at this. We're not told what the rate of change is, right? We're not told what the slope of the line that we would use to graph this function would be. We don't know m, so let's just write that m equals, darn, let me get my writing tool, m equals, we don't know yet. We don't know what b equals yet either, right? So how in the world are we going to write the function that represents the cost of renting the hall? Well, we do know that this is a linear relationship. So it can be represented as a linear function and graphed as a line, right? Why? Because we know that they charge a flat booking fee and then a constant charge for each party guest. So we know that the rate of change is constant. So we know it's a linear relationship. So we know we can write this as a linear function. Let's call it f of n equals m times n plus b, where n is our independent variable, right? And it represents the of people attending, number of people attending the party, or the number of party guests, right? And n, I mean, you can see that this function is the same as if we used the variable x for our independent variable, right? I just think we should get some practice seeing it written as n because, of course, the independent variable can be represented by any letter, right? We just normally use x, but we can use n too, and it's the same thing, right? As you can see, it goes in the same location in the formula where the independent variable x always goes, right? Okay, so we know that this is a linear relationship. We know we can write this as a linear function like so. All right, so how are we going to figure out m and how are we going to figure out n? Well, let's see what kind of information we can extract from what we're told. Here's what we're able to extract. We're able to extract two data points, okay? We're able to extract two data points. All right, let's read through and figure out if we can find those two data points. Well, we know that if she invites 30 people to the party, she will be charged $225, right? We know that if she invites 30 people, she'll be charged $225. In other words, we know that f of 30 equals 225, okay? That also means that we know one one point on the line that we would use to graph this function, right? We know that if f of 30 equals 225, we know that there is a point on the graph of the line that we use to graph this function, 30, comma, 225, right? Because we know there's one point on this line that represents the function where the independent variable is 30 and the dependent variable is 225, or stated in other words, where the input is 30 and the output is 225, right? So that's important. We also know another data point, right? We know if she invites 55 people, she will be charged $350. So we know that f of 55 equals 350, right? We know that there's a point x2 comma y2, right? We know there's a point on the graph of this line where the x coordinate or the independent variable coordinate is going to equal 55, right? And where the y coordinate or the dependent variable coordinate will equal 350, right? Because we know that we know that if we input 55 into this function, our output is $350, right? Okay, so let's see if we can use that information to let's find the value of m first, okay? Let's find the value of m. Well, we should be able to find the value of m, right? Because we know that m is equal to the slope of the line that we will use to graph this linear function, right? And we know that m is the change in y, right, divided by the change in x, right? We know that which we sometimes call rise over run, right? And we have our x1, y1 coordinate and our x2, y2 coordinates, right? How do we know that 30 comma 225 is the x1 comma y1? Because it has the least x value, right? Because the formula to find the change in y over change in x is y2 minus y1, right? Divided by x2 minus x1, right? Okay, so let's plug in our information. We know that um, 350 is y2, right? So we got 350 minus 225, right? Divided by x2 minus x1, that's 55 minus 30, right? Okay, what's 350? 350 minus 225, right, is 125, right, divided by what? 55 minus 30 is 25, right? And finally, what is 125 divided by 25? Positive 5. All right, so from just that information, we were able to figure out that m, or the slope, is equal to positive 5, right? So let me make some room down here. We don't really, well, let's maybe keep that. Let's maybe keep that. And let's say at least we know for sure that m equals positive 5. All right, that's half the battle, right? Now we need to find b. Well, how do we find b? Well, remember, we take one data point that we know is on the line, right? Let's in this case use 30 comma 225, right? All right, let's make some room. Let's make some room. What do we know? We know that f of n equals 5n plus b, right? We know that f of n equals 5n plus b, right? And we know that f of we know that f of 30 equals 225, right? Okay, so we know that if n equals 30, f of n equals 225, right? So we can plug in 225 for f of n, and we can plug in 30 for n. Remember, this is what we spent some time doing last lesson, right? So let me make some more room. Let me make some more room here. Okay, we're just going to simplify this algebraically and then solve it, right? What's 5 times 30? That's 150, isn't it? 150 plus b, 225 equals 150 plus b. We're going to subtract 150 on both sides, right? And what are we going to get? We're going to get 75, right? So that crosses out. This is going to be 75 equals b, which of course means b equals 75, right? All right, so what have we found out? We found out that in the graph of in the function of this relationship, let me get my brush back. M equals 5, B equals 75, right? Okay. Now that we have that, we can get rid of pretty much everything else, right? There we go. There we go. We know that since this is a linear function, f of n equals m times n, whoops, equals m times n plus b, right? We know m is 5, we know b is 75, so we can finally write f of n equals 5n plus 75. And that's our answer. And that's how we're able to figure out the graph of a function. Rather, I should say how we're able to figure out formula of the formula of a function if we only have two data points.